So this video has a lot of different parts to it, so we're just going to go ahead and talk about the difference quotient, the first two questions up on top there. And so if I could put difference quotient simply, it basically we're talking about, so f of x is a function, and we plug in x, right? So for the function, we plug in a value for x, and it spits out an output or a y value. When we do that, again, there's only one option, but what if I want to track the change by adding another variable or number to it, such as h, so x plus h. What would the function look like if I added that element to it? And then, of course, we want to find the average between what I originally plugged in, then plugging in the new value, and what changes do those make together. So that's essentially, in a nutshell, difference quotient. But procedurally, it's not that bad. So notice how in number 1 and 2, I tell you f of x plus h minus f of x, all divided by h. Okay, so the way that it works is I plug in x plus h into x. So that would give me negative 5x plus h plus 7. And then I plug in the function, which is just minus f of x. So I'm going to put minus parenthesis negative 5x plus 7. Now the reason I put negative 5x plus 7 in parentheses is because, remember, I have to distribute the negative. The negative applies to the entire function, not just the first term of the function. So I have to make sure I put parentheses, and that helps remind myself I have to change the signs of the entire function, all divided by h. So if I distribute negative 5, I get negative 5x minus 5h plus 7. Distribute the negative makes it positive 5x plus, or excuse me, negative 7, all divided by h. Now with difference quotient, you know you did it right if all the terms without an h go away or cancel each other out. So all the terms with h stay, all the terms without an h get canceled out. So negative 5x does have positive 5x, so those cancel out. And then positive 7 does have negative 7, they cancel out. So I have negative 5h over h. And what happens to h? They cancel each other out, h over h, and so my answer is negative 5, or the difference quotient for this function is negative 5. And of course, we can get more complicated. So look at number 2. The function is a quadratic, and again, the procedure doesn't change. Now we just have more to plug in. For example, so I'm going to still plug in x plus h into both x's, now the x in front of the, or behind 3, and the x behind negative 5. So again, I'm just going to go ahead and write that down there. Okay, but now we do minus the entire function, so minus parenthesis 3x squared minus 5x minus 2, all over h. Okay, I'm going to start by expanding x plus h squared, which again we know the shortcut, x squared plus 2xh plus h squared. Then immediately distribute the 3, just to make things simpler for myself. So 3x squared plus 6xh plus 3h squared. Then distribute the negative 5, which makes negative 5x minus 5h. Distribute the negative into the next piece, which is negative 3x squared plus 5x plus 2, all over h. And remember, I did difference quotient right. After I get rid of the parentheses, everything without an h should cancel out. So 3x squared has negative 3x squared. Negative 5x has positive 5x. Negative 2 has positive 2. So all I have left is 6xh plus 3h squared minus 5h. And this time I can't just simply cancel out an h from top and bottom. This time what I have to do is factor out an h from the top. So take an h out of everything, which leaves me 6x plus 3h minus 5. All divided by h cancels out. So my difference quotient for this function is 6x plus 3h minus 5. So notice how an h actually stayed in my final answer, but remember this is all set up for something we're going to be doing in calculus later on. So that's how you do the difference quotient.